Yes, class. So in the last class yesterday, we had started with the derivation of electric field on the axial line of electric dipole. So what is meant by axial line of electric dipole? When the point lies on the axis of a dipole. When you produce the axis, and if the point intersects with the axis that you have produced, it means that the point is lying on the axis of it, axial line of electric dipole. We had derived, we did our derivation, and we reached to the conclusion that the electric field's formula is 2kpx by x square minus a square to the power whole square. See class, somewhere you will be requiring this formula, but many a times we use ideal dipole approximation. This couldn't be completed yesterday. Let us complete this so that we can proceed towards the derivation of equatorial point. See, ideal dipole approximation means that x is very much greater than a. It is very much greater to a. What is your x? X is the separation of the center of dipole and the point of calculation. If this length of dipole is very small, if your dipole is very small, this a is very small, but this x is very huge. Let's say the separation is very huge, but the dipole is very small. This much is the dipole. So will there be any effect if even if you are holding the dipole? Ideal dipole approximation means dipole size is very small, x is very much greater than a. So see, if x is very much greater than a, then x square minus a square can be written approximately equal to x square. See, it's like x square is a very big quantity. Let's say 1000. A square is a very small quantity. Let's say 1. So when you subtract 1000 minus 1, what do you write? 999. So 999 can be approximately written as 1000. It means we are writing this term back. We are just writing this term back. Because a is such a small quantity and a square further becomes a small quantity. X square is a small quantity, further it becomes a very bigger quantity. So when you subtract these two, this has a nullifying effect. It's like if x is some 39.2, something like this, a is 0.01. So you will always use 39.2 instead of it. This is why we use ideal dipole approximation, because in most of the cases, the dipole's size is very much smaller in comparison to the separation from the center to the point of calculation. So we write it as x square. What was our formula? Formula was 2kpx divided by x square minus a square. No, so instead of that, we'll just write x square. The formula was x square minus a square to the power whole square. Yes, instead of x square minus a square, what we can replace this term as? Just x square. So electric field becomes 2kpx divided by x square instead of this, and then this square is left. What does it become? It becomes 2kpx divided by x to the power 4. 1 power, this gets cancelled. So final electric field's value is 2kp by x cube. Fine. So electric field, this is inversely proportional to cube of it, right? Electric field is inversely proportional to r cube. This you should remember in your calculations. We'll see how the difference arises in equatorial point. One thing you should remember, that the direction of axial line is exactly the same of dipole moment. This is exactly the same as that of dipole moment. See, if this is a negative charge, this is a positive charge. So from negative to positive, I have told you the direction is from negative to positive. So on the point of the axial line where we are calculating electric field, this will be exactly the same. If this is pointing towards positive x-axis, rightwards, this will be also positive x-axis. This is how you find out the direction. Note down this in addition to what we have done yesterday. Then we'll complete. Till here, you all have written. Completed from here, mention ideal dipole approximation. It will be used everywhere. Then we'll see the derivation of equatorial point. Electric field on equatorial line of dipole. Now, what is meant by equatorial line? When we extend the axis of the dipole, then on the point of the axis, we call it as the axial line of dipole. Perpendicular to this point, if you are having any point perpendicular to the dipole's axis, that is your equatorial point. For that, you have a separate formula. Now we'll be using superposition principle also here. See, because let's say this is a negative charge, so electric field will be towards this, right? Electric field will be towards this. Let's say the angle that is formed is some theta. The angle that is formed is theta. So electric field, because of negative minus q, is pointing towards the downwards. And see, this is positive. So because of positive, the electric field line will move away. So this is E plus Q, electric field due to plus Q. If this angle is theta, suppose if I take a line parallel. So according to alternate angles, this will be theta, right? This will also be theta. And if I take this as theta, according to corresponding angles, this will be theta. Let us resolve them. The axis, the angle with which the axis is there present, the axis with which the angle is made, that axis has cos theta. So once we resolve them, E minus Q, you get E minus Q cos theta over here. And perpendicular to it, you have E minus Q sin theta. Yes. E plus Q. Here again, you will have E plus Q cos theta. And this will be E plus Q sin theta. Clear? Let's have a look at the resolution of vectors which we have done. E minus Q sin theta is downwards. E minus Q cos theta is towards the left. Then again, E plus Q cos theta is towards the left. E plus Q sin theta is upwards, right? Now we have this with us. This we have to find out. Now, see class, whenever we have to find out electric field, what do we do? What is E plus Q? What is E minus Q? How to calculate that? Because cos theta, we will be able to figure it out from the triangle. But E plus Q, E minus Q, electric field due to this charge at this point. We know the general formula of electric field is KQ by R square. So if we talk about the electric field, K will be the constant, Q will be this Q. What will be R square? See this entire separation. So if this is A, this is small r, we can find out this entire length. This is A, this is B, this is O already. Let's take this point as C. So AOC, what is AC? See, in triangle AOC, this triangle, this is the hypotenuse. So AC will be equal to under root R square plus A square. Right? So we have the separation also. Now see, E plus Q will be what? KQ by R square plus A square under root to the power square. So the square and the root will be cancelled. That becomes KQ by R square plus A square. That is E plus Q, and similarly that is E minus Q as well. Now net electric field, if we calculate along the x-axis, did you understand how to find out this? This was our triangle. This was A. So this became under root R square plus A square. Net field along y-axis. Have a look. This is your y-axis. So E plus Q sin theta will cancel E minus Q sin theta. Why? See, E plus Q and E minus Q, they are same. By magnitude, both are same. What will be E minus Q? Q by again the separation. This separation will also be r square plus a square if this separation is under root r square plus a square. So K, at this point, we are trying to find out electric field due to this Q. So K, Q and the separation square. So this becomes K, Q, r square plus a square to the power half to the power square, means under root to the power square. That becomes kq by r square plus a square. So both are same. Magnitudes are same, sine thetas are present. So how would we get the net electric field? Net electric field along y-axis, this is E plus q sine theta minus E minus q sine theta is equal to 0. Net electric field along y-axis will be 0. Whatever will be electric field upwards will be equal to electric field downwards. This will be cancelled because they are in opposite direction, same magnitude. If 5 Newton of force is acting upwards, 5 Newton of force is acting downwards, both will cancel each other. But see here, the net electric field along x-axis, this is present. Why? Because they are getting added, they are in the same direction. The resultant will be greater. So net electric field along x-axis, E will be E plus q cos theta plus E minus q cos theta. So what is electric field along x-axis? It will be double of E cos theta, right? E cos theta plus E cos theta will be 2 E cos theta. Now let's write down the values of everything. We know what is E, kq by r square plus a square. We know what's 2 is a constant. Let's find out cos theta. See class, if this is theta, this was theta we assumed. This was r, this was a, this was under root r square plus a square. Cos theta in triangle AOC, this was point was A, this was O, this was C. What is cos theta? Base upon hypotenuse, right? Base is this, hypotenuse is this. So cos theta is B by H, which is A by under root R square plus A square. We have cos theta, we have electric field, we have 2. So what is the value if you substitute everything? Electric field along x-axis will be 2 K. What is electric field? This came out to be 2 E cos theta. So 2, what was electric field? kq by r square plus a square. This is E. 2E cos theta. Cos theta is A by under root r square plus a square. Right? So I can write this as 2kqa by, this is power half, r square plus a square to the power half. And this is power 1, r square plus a square to the power 1. What is our final answer? Look, 2, let me rearrange this here itself. Q into 2a into k. I have just rearranged the term. So that we obtain is dipole moment. This is dipole moment. So what is our final answer? See, k p by 1 half plus 1 will become 3 by 2. So r square plus a square to the power 3 by 2. We put a negative sign. Why negative sign? This I'll tell you. This you understood, no? Why we did it? See, r square plus a square to the power half is here, multiplied to r square plus a square to the power 1. So what will happen? R square plus a square to the power half plus 1. That is what? 3 by 2. This is the formula. Why minus sign? I'll tell you. Now again, when we come to ideal dipole approximation, again r is very much greater than a. That is size of dipole is small. The size of the dipole is small. If size of dipole is small, so r square plus a square will approximately, it can be written as r square. It's again like from this 10,000, I am adding 1. So we'll write it as back as 10,000 only. Why 10,001? 10,001 is not a significant number. Right, in 11th class, you study significant numbers, how to write significant. So the entire formula Kp by r square plus a square to the power 3 by 2, Kp is there. This term I'll write it as r square to the power 3 by 2. So this 2 will be cancelled. Electric field is minus Kp by r cube. Now coming to this minus sign, why constantly I've been using this minus sign. Again, electric field in equatorial line is also inversely proportional to cube. The way it was inversely proportional to cube in axial. Direction is opposite. Suppose this is minus q plus q. So what's the direction of dipole? Dipole's direction is from negative to positive. So it means this is pointing towards I cap. So electric field due to this dipole at equatorial point. This is the equatorial point. This will be minus I cap, just opposite. That's why we put a negative sign, because the direction is opposite. Okay, one conclusion. See, just to remember, to make sure that you people remember, axial line, electric field was 2 kp by r cube, the shorter one was. Equatorial was kp by r cube. Fine, minus kp. Direction was same as that of dipole. Direction is opposite that of dipole. Now, one relation that is asked in the exam regarding axial and equatorial. If you take the ratio of E axial and E equatorial, what is E axial? 2 kp by r cube. This was the difference. Multiplied by equatorial is kp by r cube. R cube will be cancelled. Kp will be cancelled. So you have a relation. Electric field due to axial line is twice that of equatorial. This is a conclusion also that you have to remember, and these are the points of differences that you have to remember. Note down the entire derivation, mark this as important. This can come, both the derivations, electric field due to axial or equatorial, both can come. Note it down. Wherever you're not able to understand, let me know.
Excuse me, ma'am.
Yes, Fadil, say.
Ma'am, can you explain how we resolved the vectors again?
See, resolution of vectors occur in this manner. This is a vector A.
Mm.
If this is theta, so the axis with which the angle is made, see, the angle is not made here, the angle is made here. That becomes cos theta. And now the axis which is perpendicularly left, that becomes sine theta. So here we had electric field minus q pointing towards it. So we resolved it into, here theta was made. So here theta was made, alternate angles, no, here theta was made. So this became cos theta, perpendicular became sine theta. Here, because of positive charge, the electric field was here. So, and this was theta. So this became again cos theta, perpendicular became sine theta. Clear?
Yes, ma'am.
We are subtracting the electric fields because they are in opposite direction. Class C, two dipoles are given to you. This is P1, directly direction is given to you. This is P2, direction is mentioned to you. Now we have to first identify whether this point is lying on the axis or not. See, when we talk about this point, how to identify whether the point is lying on axial line or equatorial line. Just drop the axis. So this point is lying on the axis. So this means this is equatorial line. So if the dipole is situated towards the right, our electric field will also be situated towards the right for the first one. Now second dipole. This is also lying on the axis. See, this point A, this is still lying on the axis. So what is the direction of dipole? Upwards. So electric field second will also be upwards. So what do we have? We have E1 like this. We have E2 like this. And both are what? Both are axial points. So what would be your answer? Net electric field would be vector sum of E1 plus E2. Instead of writing it in polar form, I'm writing it in Cartesian form. This becomes 2 kp by r cube. R is given. This is I cap plus 2 kp2. This was P1. This is by r cube. And that was above j cap. That's your answer. Further, if the values are given, you can use the formula. This also formula. This can be used. Under root E1 square plus E2 square. Note down this question as well. Fadil, what didn't you get?
I didn't get the question.
Question is, you have this dipole. This is point located. This is another dipole point located. You have to find out the resultant electric field. So for this dipole, instead of the charges that are given plus q and minus q and plus q, entire dipole is given to you. No mention of the dipole's calculation and everything. Just the dipole is mentioned. So
Okay.
point is lying on its axis. So this is axial point. Yes. So what would be E1? 2 kp1 by r cube. Till here, do you agree?
Yeah.
Direction is same as that of dipole in axial case. So if this is pointing towards x-axis, this will also be pointing towards x-axis. This is what we have studied regarding axial point. So that's why we have written I cap over here. So 2 kp1 by r cube I cap. Now come to the second one. This is the dipole moment situated upwards. This point we want to find out whether it is located on the equatorial axis or axial axis. So extend the axis. This is its axis. This point is still lying on its axis. Had it been perpendicular, it would have lied somewhere here or here, but it is lying on its axis. So it means second one is also axial. What would be the formula? 2kp2 by r cube, because dipole moment is p2, separation is r. Till here, do you agree?
Okay. Yeah. Okay.
Now, the
Understood.
direction of this dipole moment is upwards. And for axial, we use upwards only. Let's assume that this point was equatorial. So this would be then downwards, exactly opposite to direction of dipole. But since this is axial, this is pointing upwards. So direction of electric field will also be upwards. So net electric field will be J cap. We don't have the values. What would we substitute? This is our final answer now. Got it?
Okay.
Clear, Fadil?
Yes, ma'am. Understood. Ma'am, if we had equatorial instead of an axial P2, so would we then subtract to find the net electric field?
See, if you have equatorial, then you will put minus in the direction.
Minus. Right.
Yes,
Right.
like suppose minus j cap, minus I cap. Now, whenever we solve the vectors further, we use parallelogram law. So these are making 90-degree over here. So you can use your parallelogram law, right?
Okay.
See class, we have to start with torque. Torque is a vector quantity and it requires cross product. So just a quick revision of your class 11th, because though you people have just studied this in class 11, but let us revise because cross product will be used and you will be requiring all these concepts. If two vectors are subtending angle theta and we have to calculate their cross product, firstly sin theta comes in. N cap is just showing direction. What direction is? This is how we go about the direction. Right? Just write I cap, J cap, K cap in one corner of your sheet. And if you are going clockwise, then take the third quantity as positive. For anti-clockwise, take it as negative. Now see, I cap, J cap, K cap, you have written in the corner of your sheet. Now go from I cap to K cap. In which manner are you going? You are going clockwise. So what is the quantity that is left? K cap is left. So we'll write K cap first. Now regarding the signs, in which direction are we moving? We are moving clockwise. So it will be plus K cap. Let's take the opposite. If we are moving from J cap to I cap, if we are moving from J cap to I cap, which is the third quantity left? K cap. So it would be K cap definitely. And in which direction are we moving? It is anti-clockwise, opposite direction to the way the clock moves. So anti-clockwise is negative minus K cap. J cap to K cap plus I cap. K cap to J cap minus I cap. K cap to I cap, K cap into I cap, that is J cap, and I cap cross K cap, that is minus J cap. See, cross products, they are anti-commutative. We write no in addition and subtraction, we write in addition, 3 plus 2 is 5, 2 plus 3 is also 5, 3 into 2 is 6, 2 into 3 is also 6. Yes, but here it's different. I cap cross J cap is K cap, but J cap cross I cap is not K cap, it's minus K cap. So that's why this is the thing that you should be careful with. Make a note point and write it down. Just make a note point, revision of cross product and write this. Yes, all those who have completed, you people can start leaving. Please attempt your after class assessment today. It is based upon what we have studied today. Okay, thank you so much, class.
Okay, ma'am. Thank you. Ma'am,
Yes, Fadil, say.
ma'am, I was saying yesterday I checked the after class assessments and it wasn't showing anything for me.
You are not able to log in into it.
No, ma'am, I've logged into the account. I have an account, but the after class assessments they never show.
They are not showing. Just contact the team once after your prayer. No, namaz padh lo, uske baad just contact the
हाँ,
team once. Okay.
okay, ठीक है, okay. Thank you, ma'am.
Ma'am, ma'am, ma'am.
Yes, Deborah.
Yes, ma'am. Yesterday's homework question. I didn't understand that.
Deborah, just please send me the screenshot of that question on WhatsApp group. You are on the
No,
group,
ma'am, I
no?
didn't find the question itself.
Hmm?
I didn't find the question itself.
Okay. Can you tell me the question number?
It just said that.
I'll find myself. Just give me a hint at least. How will I then solve without knowing the question?
It said that